part 7B97E, line 22, 7B97, Ballistic Transport takes Formula 5, UFO 5G Wow Seti. You want to start at number 1. Okay? That's the alien radio signal. July 8th was when I was working on this, 2013. Today's August 7th. This is about the 5.8783279 E6 plus 60 QUJ5, Mayan symbol for 0. Higgs Ballistic Transport, formula number 5. CORE UFO Engine, communication laser beams, crystals, superlattice, quantum dots, water molecules, expanded from line 22 WOW data. So it's from a previous video of line 22, 7B91, Aharonov-Bohm Oscillations, quantum dots formula, 5G WOW Seti. Quote from wiki was ballistic conduction or ballistic continues. We're talking about the theory of ballistic conduction, which is scattering mechanisms in general. Carriers will exhibit ballistic conduction when L is greater. I'm not sure what that symbol means. Sorry, I don't know what this means. And where L is the length of the active part of the device, a channel in MOSFET. This upside down Y thing, MFP, is the mean scattering length for the carrier, which can be given in Mathiessen's rule written here for electrons. And then there's some sort of calculation here with ones and pluses, and then these different boundaries underneath. So it says where the upside down one, EL-EL, is the electron scattering length. Next one is the acoustic phonon emission and absorption scattering length. The next one is the optical phonon emission scattering length. Then optical phonon absorption scattering length. Then there's electron impurity scattering length, the electron defect scattering length, and then the electron scattering length with the boundary, and finally in the total electron mean free path, electron scattering length. In terms of scattering mechanisms, optical phonon emissions normally dominates, depending on the material and transport conditions. There are also other scattering mechanisms which apply to different carriers that are not considered here. Remote interface phonon scattering, umklap scattering. To get these characteristic scattering rates, one would need to derive a Hamiltonian and solve Fermi-Golden's rule for the system in question. So, July 21st, formula from the data. Carriers will exhibit ballistic conduction scattering mechanisms. Length of the active part of the device is MOSFET. Mean scattering length for carrier, Mathiessen's rule, electron mobility. The keyword Mathiessen's rule is electron mobility. Google in another video. Formula continues. Electron to electron scattering length, acoustic phonon emission absorption scattering length, optical phonon emission scattering length, optical phonon absorption scattering length, electron impurity scattering length, electron defect scattering length, electron scattering length with the boundary, total electron mean path, electron scattering length. Scattering mechanisms, optical phonon emission normally dominates material transport conditions. Other scattering mechanisms apply to different carriers. Remote interface phonon scattering, umklap scattering, I'm going to Google in another video. And the keyword umklap scattering will be in the next video. Thanks for watching.